so when we start with number 6, tell me what is different about number 6 than all of them we did yesterday and all of them that you just did with your friend in the activities. It's not just 2 terms and 2 terms. What were you going to say?
There's 3 terms on the left.
3 terms, and there's 2 variable terms. Right? And so now it's like, well, which one do I move and what do I do? This one's bigger. This one's harder. Okay? And so remember, the main job is we're going to move. How many of you have ever moved before? Like moved a house. When you get ready to move, what is the first thing you have to do? No, let's not even say that. Yeah, you do clean. I like that. Let's not even say that. Let's say, if you're going to move, would you do this? Would you go in your room and unplug your Xbox and walk it out to the moving truck and stack it in there? And then walk back into your room and get your favorite sweatshirt and walk it out to the truck and put it in the truck. And then go back to your bedroom and pick up your favorite blanket and walk it out to the truck and put it on the truck. Is that how you move things? No. What happens if you're going to move? What does your mom, dad, parent, guardian, whoever usually make you do? You have to pack. Right? You pack up all of your Xbox gaming stuff. You pack up all of your favorite sweatshirts. You pack up all your stuffed animals. You pack up all your makeup. You pack up all your whatever into a box, and then you pick up the box and you move it. And when we solve these equations, we have to follow the same rules. We have to pack, write that on there with me, before you move. So we're still going to do the same things we've been doing yesterday. But if there's ever anything that has to be put together, we have to pack them up before we move them around. So looking at 6, I have 6x plus 12 plus 4x. I need to pack up, and by pack we mean collect up the like terms, 6x and 4x. And I'm sorry for the delay when I'm recording. It's really long today. That would be 10x plus 12 equals 3x plus 47. And now I have created an equation that looks just like what we worked on yesterday, and you spent the first 15 minutes of class getting real comfortable with. Would you agree? Yes. Solve it from there right now. Do you agree with your seats, partners? How many of you started with minus 3x? Is that the only way to start?
No.
No, but I started with minus 3x as well. And why did I do minus 3x? Because I wanted to move the variables over there, and that kept my 7x positive. And then I subtracted 12, x equals 5, yay? All right, why don't you try number 7? You got lots of packing to do in this one, do you agree? Make sure, now again, I'm not going to make you draw this wall. Does everybody see my wall? But part of the reason I do that is because when you start this packing before you move, I get some people that are like, 5x, negative 3x, 2x. Can I pack all those together? No, you got to pack your bedroom, your siblings pack their bedroom, and you don't put none of their stuff in your boxes. Because you don't like your siblings right now, but you will love them later. Trust me. You with me on that? You understanding, right? I know you might not agree, but I promise you will. I packed the left side to 2x plus 7, and I packed the right side to negative x minus 8. Do you agree? And now I've created this type of equation that we're feeling more comfortable with. 2 terms, 2 terms. If I can make it look two terms, then I should be like, I can solve this. I'm good. Okay? Finish. Or did you already finish?
Yeah.
Are you guys so fast? I would finish by adding x, which would give me 3x plus 7 equals negative 8. And I would subtract, not 8, I would subtract 7. 3x is negative 15, and I would divide by 3. X equals negative 5. Realistically, once you know what you're doing, solving these does not take exponentially long. You should be able to solve a problem, an equation, if you know how to do it, in less than a minute. Would you agree?
Yeah.
Okay. Let me see about our geometry connection. So one of the things we're going to try to start doing is just constantly adding in real-world applications. This is the first one. This is a geometric shape, two intersecting lines. Two intersecting lines create what we call vertical angles. Okay? That is a geometry 1 term that you will use in chapter 1 and 2 of geometry. I know because I've been working on it all fall, all the time. And that's whenever you have two angles, so like this angle and this angle are vertical. They kind of go in opposite directions. Does that make sense with everybody? The cool thing about vertical angles are they are equal. If you know they are equal, and I said find y, typo on my notes, find y, what would you do? What is the whole topic this week about? Equations with variables on both sides. So I'm probably going to use that for this problem. What are you going to write, Cooper?
I was just going to write an equation of 9y plus 7 equals 2 plus 98.
9y plus 7 equals 2y plus 98. Now, I would not expect you to know that if you didn't know what vertical meant. But now, whenever you see that scenario, you feel like, oh, these are equal. I can set them equal. And if I set them equal, what did I create? Variables on both sides. You go, see if you can figure out what y is. Now, this has been interesting all day. Some of you think, if it's not a math fact, I can't do it. If you don't know what 91 divided by 7 is, what are you going to do? Go to the side and calculate it. That's probably for you, D. Is Miss Curtis? I do? Sure. Here's the assignment, and like I said, watch this video that I post. That'll give you some help on the others. And we're going to get through 20 today. You can fast forward because this will be at the very beginning of the notes. Did you guys figure out how big it is? Y is 13. Now, if this question said, how big is this angle, would 13 be the answer? What would I have to do to figure out how big it is, Alexis? 13 degrees? No?
Substitute 13 for y.
I'd have to put 13 in here because it says the angle is 2 times 13 plus 98. Or I could put it in the top one, which I scribbled over twice. I don't know what it says. 9 times 13 plus 7. Either one would tell me how big that is. Does that make sense? It's very important you read the question. Let's see who's got a big brain for number 9. Number 9, pretty challenging question. And something got left off my PowerPoint here. So I'll write it in. It's on your paper, though. This is always an interesting question. Okay, these two circles are identical. What does that mean?
Both the same.
They're the same. What is the area? Ooh. What is the area formula for a circle? This has been hard for people to remember. What do you think, Brielle?
2 pi r.
Nope.
R squared times pi.
Pi r squared. A equals pi r squared. Now it says leave your answer in terms of pi. So I don't need to mess with this. So what do I need to figure out my answer here? I need what value? To do this equation, what do I need? I need r. So what is r? And this is where I get somebody who's really smart. Ms. Kearns, r is x plus 10. That is true. But do I have any idea how to square this? Not in 7th grade math. Not even in 8th grade math. You learn how to do that in algebra. What is the topic of the day? Variables. So I'm probably going to need to use that. Anybody got any ideas?
Do 6x equals x plus 10.
It does not, but that is a great start. Did everybody hear what he said? You can do 6x equals x plus 10 because they're identical. And that's getting variables on both sides. He is on the right track. He's, hot, cold. He's hotter than all of you in that hot, cold business. He's just off a little. Yeah, what do you think?
6x equals to twice x plus 10.
Oh, okay. So he's saying 6x equals 2 of x plus 10. Why is he saying that? He's right.
Because x plus 10 is only half the radius.
X plus 10 is only the radius, and 6x is the
Circle.
diameter. That's a harder equation than I use. Can anybody think of a different equation that we could use? I used an easier one in last class. What do you think?
6x.
Whoa.
6x.
Nope, I'm not using 6x. Come on, big brains, let's go.
3x.
Why don't I use 3x? Because 6x is the whole thing. What's half of that? So I could use 3x equals x plus 10. Do you understand that these two equations are exactly the same equation?
Yeah, you can divide them both by 2.
I can divide this one by 2 to get 3x and set those equal. Or I can double this one to get those equal. Either one, I don't care which one you solve it now. What do you get in either one? X equals 5. Is 5 my answer? No, 5's not your answer. So cross that one out. 5 is x. This is where you got to be thinking about using your answer on through the problem. If 5 is x, how do I find the area? Oh, 25 pi. No, that's not even up there. I plug it in and say, okay, well, what's the rate? If x is 5, what is the radius? 15, right? The diameter would be 30. That's double. So somebody's like, oh, it's 30 pi. No, not 30 pi. And it's not even 15 pi. So it has to be 225 pi. Good, I'm done. No, why isn't it 15 pi? R is 15. The formula for area is pi r squared. 15 squared. Now, I would not make you memorize pi r squared. I would give you that. But you have to be able to plug it in and say, how do I get there? 15 times 15 is not 30. 15 times 15 is 225. Turn the page and try number 10. Turn the page and try number 10. Now, if you sit out there and look at me like I have no idea how to do number 10, I'm going to be really mad at you. Number 10 ought to sound really, really, really familiar. Why should number 10 sound really familiar? Because we already did it. Before fall break, we learned how to write consecutive integers. How do you do a consecutive integers? You start with n equals an integer. So everybody remember doing that? And how do I write the next integer? Somebody besides Alexa better show up today. How do I write the next integer?
N plus 1.
N plus 1. You can't even write the equation if you can't remember that part. Now that you've got those two written down, see if you can write the equation. Remember, what's it got to look like? Variables on both sides. That's a topic for the week. The greater of two consecutive integers, which one is bigger?
N plus 1.
N plus 1 is. What does is mean? Equals 15 more than. Twice the smaller. Is that an equation with variables on both sides? On your unit test, this is all you will do. Even if it says find the integer, that's all you'll do. You'll write the equation. You'll write the variables. You'll set it up. You'll define the variables. You write the equation. You'll be done. Does everybody feel like they know confidently how to solve this?
Yes.
All right, let's move on to what happens when we start adding more stuff. What are we going to do when we have distribute and we have lots of terms? Right? What we've got to make sure we understand is that you have to distribute first. And there's actually a step in here. I want to fix these next year. I don't want to just say you got to distribute and then move. I want to say you've got to distribute. Then you got to pack. And then you move. Back to my moving analogy. If you've ever moved, your mom goes and finds some big boxes and brings them and distributes the boxes in the house. Here's boxes for your room. Here's boxes for the kitchen. Here's boxes for the living room. And then you pack those rooms in those boxes. Does that make sense? So I'm going to pass the boxes out. I'm going to collect the stuff up and pack. And then I'm going to solve. Let's try number 11 together. I'm going to distribute. Do we all agree? 2x equals 7x plus 35. Now this is the first one where I told you to try to keep the variable positive. Makes the problem harder. And so I said keep the variable positive whenever you can. But if that makes it harder, don't do that. If I want to solve this equation and I have one side with no numbers, I'm moving the variables there. Because that creates a one-step equation. If I move the 2 over here, I have a 2-step equation equal to 0. That's more work. That's more steps. Does that make sense? So I'm going to start with minus 7x. Does everybody agree? Negative 5x equals 35. And I'm going to divide by negative 5. And x equals negative 7. Try 12 for me right now. I hope you all got 5x plus 10 equals 3x minus 12. Yay or nay? Is that making sense with everybody? And then I'm going to subtract 3x. 2x plus 10 is negative 12. Don't drop your negative. Thumbs up, thumbs down. Subtract 10. 2x is negative 24 divided by 2 is not 24. 22, Miss Kern's thinking ahead. That's negative 11. Yay? Do you see how once you get down here, it's always the same pattern, same pattern? So like once you get there, you should be like, this is, I got it. It's simple, simple, simple. It's all the new stuff up here at the top. Agree? You try 13. You start every problem with your checklist. Do I have anything to pass out? If so, pass it out. Do I have anything to collect? If so, collect it up. And then you move things around. Once you get your answer, compare with your seat partners, see if you're on the right track together. I didn't get 3. I didn't get a negative. If you don't have what I have, you should be looking through the layers of work that I have to figure out where did I do something different. Check, did you distribute correctly? 20 minus 5x equals negative 3x plus 4. I added 5x. Then I subtracted 4 and I divided by 2. Yay or nay? Did you find your mistake, Ollie? Well, look through your layer and see where you have a different number than me. You probably need to find your glasses. That would be helpful. Tell me what's in number 14 that starts to stress kids out. A fraction. Look at 14 and then turn the page and look at, I don't even know, 18, 17, 18, 19, 20. Are they the same? Is the fraction in 14 the same as the fractions in the ones on the back? No. Does everyone see a difference? I want to make sure that when we start to do the back, you understand that what we're going to learn on the back, you would not need on the front. Because when I look at this one on the front, yes, there's a fraction, but tell me what's going to happen to my fraction when I distribute a 12. It's going to fall out, right? A fourth of 12 is a whole number. So when you see fractions, you don't immediately need to panic. And I'm going to teach you a tool to handle the ones on the back in just a minute. But right now, just because you see a fraction doesn't mean you need to change what you're doing. You're going to distribute. On the left, you're going to get negative 2x plus 10. Is everybody following why that would be negative 2x plus 10? And on the right, you're going to get 24 minus 3x. Solve that from there for me now. Well, part of this is because it's like you have it written so big and then so small. You're going to have to figure out a way to write that you can not lose things in yours. Right? That's what happens. I would have added 3x. Here's that 14 coming for you now. X plus 10 is 24 and subtracted 10. X equals 14. Yay. Because we're getting close on time, we're going to skip 15 and 16 and we're going to do those on Thursday. And we're going to turn over these fraction problems because you've got to figure out what you're going to do when you see those. We will be doing those problems. And what I'm going to do today is I'm going to teach you a tool that you can use to make the problem easier. First thing I want you to understand is you don't have to use this. You can take all of those 4 problems and any like it and say, okay, I'm going to move all the x's to one side. I'm going to move all the numbers to the other. But in doing so, you're probably going to have to get common denominators, rewrite them with common denominators, and keep track of all that. Does that make sense? Then when you have to clear the fraction out, you're going to have to multiply by the reciprocal and all of those things. So, lots going on there. And so one of the ways to make this problem easier is to use the tool called clear the fraction. And we've talked about this briefly in the past. But I want us to understand to do this tool, there's no rule that says you have to do it. It's just an algebraic skill that makes hard problems easier to do. Okay? And you got to follow one step. We are going to multiply. We are going to multiply every term. That's the key. By the LCD. What's the LCD? The least common denominator of all the fractions given. And so basically what we are going to do, instead of like changing these and changing those, we're going to take the equation with all these parts and we're going to make it a whole bunch bigger so all the parts leave. Okay, so I wrote a really simple one for the first one. I don't even know if I would use this on the first one because it's so basic, but I'm going to show you on a really simple one when we look at number 17 together. If I have 4/7 equals 18 minus 2/7, what's the least common denominator of those two denominators? 7. That's nice, right? It won't always be the same number, but what we're going to do is we're going to put parentheses around the whole equation, and we're going to make this whole equation 7 times bigger. And if I make this whole equation 7 times bigger, that eliminates the fraction. So watch with me. You're going to take 7 times 4/7. What is 7 times 4/7? 4. That cleared the fraction. You also have to make 18 7 times bigger. What is 7 times 18? And if you don't know that mental math, you might not. What will you do? 18 times 7. I'm not doing it for you. Seven groups of 18 is? All of you out there waiting on somebody in class to do it for you. Never going to finish. 126. And then I'm going to take 7 times 2/7. Equals 2m. Or not equals, minus 2m. This equation right here is equivalent to that. And that looks like something we've been solving all day. Would you agree? Yes. Much easier than all those fractions. How would I solve this? I would add 2m. 6m equals 126. Divide by 6. M equals 21. That was way easier than fractions and common denominators and carrying and borrowing and all of those. Would you agree?
Yep.
How about 18? I've got ninths, I've got halves, I've got thirds. What is the least common denominator of all of those denominators? What does 9, 3, and 2, all of those go into? Jacob? 18. I'm going to make this 18 times bigger. That is the process of clearing a fraction. We just make it till there are no fractions. So what is 18 times 2/9? 4 n's. Now some kids are like, where is she getting that? Okay, it's little mini math problems. 18 times 2/9. We've done that math problem this year in our class. What is 18 times 1/2? Plus 9. What is 18 times 2/3? It's about this time. I'm so confused what she's doing. I'm multiplying every term to clear the fraction. 18 times 2/3. That's a 1. That's a 6. Oh, that's 12. And 18 times 2. 36. Does this look like the equation at the beginning of class? I said this is what you have to be comfortable with. Did I just make that equation a comfortable equation where it looked really messy before we started? If you can make it comfortable, you should be able to solve it. We're going to continue. I'm not going to finish that one just because I want to make sure we try all the hard ones. What is the common denominator for 5, 10, and 2? 10. Now this one is tricky. Pay close attention. This on the right is one term. So when I pass this out, I'm passing 10 out here, I'm passing 10 out here, and I'm passing 10 out here. I'm not passing 10 out to the half, to the n, to the 3, because that's all one thing together. And so once I take n times the half, I've already multiplied it. That would be like double and triple multiplying numbers. We wouldn't do that. Does that make sense? What is my new equation going to be? 2/5 of n is 4 n's. 1/10 of 10 is 1. And 1/2 of 10 is, I just gave it away, didn't I? 5n plus 3. Now that doesn't look like what I'm comfortable with yet. What do I have to do now?
Distribute.
Now I have to distribute. Now somebody's asked me earlier today, like, could you distribute first? Yes. But that would have made it even more distributing than the big number, right? Because you would have had a half n plus 3 halves. I'm not going to distribute. I'm going to always clear and then distribute. Because then I have less fractions. Yes?
Did you purposefully make all the first numbers 4?
I didn't. It just happened. 4n plus 1 equals 5n plus 15. Can everybody solve that from here? Subtracting 4n. 1 equals n plus 15, and I would subtract 15. What would n's final value be? Negative 14. You do 20. You try 20. Does it matter that 20 has an inequality sign? It does not matter. It doesn't change the process at all. Who's got the common denominator for 2, 4, 6, and 8? What do you think, Blythe? What's the common denominator for 2, 4, 6, and 8? Nope. 6 doesn't go into 8. It's got to be what 2, 4, 6, and 8 can go into. What do you think, Jenny? 24. All 4 of those numbers go into 24. How do you figure it out, Ms. Kearns? I just waited till somebody told me, right? I always start with the biggest denominator and go through the multiples. So I would have started with 8 and said, do they all go into 8? Nope. Do they all go into 16? Nope. Do they all go into 24? Yes, that's my least common denominator. What's a fourth of 24? 6x. Yay or nay on the first term? What's half of 24? 6x plus 12 is greater than or equal to? What's an eighth of 24? And then we get to the last one, 5/6. Some people are like, I don't know how to do 5/6 of 24. Well, 24 over 1, 5 times. Last class I had somebody saying, what's 24 times 5? Don't do that. Cross cancel. 1 and 4. Oh, it's just 20. Does this look a heck of a lot easier than the one above it?
Yeah.
Tremendously. Do I have to clear the fraction? No. It is a tool. You could have said, I'm going to subtract. Ooh, would I subtract 1/8 or should I subtract 1/4? I don't know. Is everybody following? Can we handle it? Today's assignment is assignment number 26. No, 27. It's 3-4 day 1 practice. Okay? The front side has an answer bank. So if you get something that's not down here, you know you messed up. The back side doesn't. And the last two are practice writing equations. If you turn in a problem with answers circled here, I'm counting you, giving you a 7. Because you didn't read directions, you didn't follow directions, you didn't work on defining a variable, writing the equation. The answer is the equation. Well, define the variable and write the equation. It even says it. It just says, write the equation to find the length and width. I don't need the length and width. 27 is where we are. I want everybody to get number 1 done before the bell rings.